Hey everyone, today we're going to talk about the ellipse, which is the next one of our conic sections that we'll be exploring. The ellipse is a little bit different than the circle, has its own set of characteristics which we're going to get into. You'll notice in the pictures below the wording here, and this is from your notes. So if you haven't printed off your note sheet yet, you might want to pause this video, print it off so you have it with you and you can copy the notes as we go. But the ellipse looks like an oval, and by definition it's a set of all points in a plane, the sum of whose distances from two fixed points, f1 and f2, are constant. So you can see here it's a little bit small in my picture, but f1 and f2 are those points there. Those 2 points are called the foci. It looks like it would be a hard C, but it's not. It's pronounced foci. The midpoint of the segment connecting the foci is actually the center of your ellipse. Okay, now you can have an ellipse that is horizontal in nature, or you can have one that is vertical in nature. When it is horizontal, that major axis, so the major axis is the longer axis. So this right here, it might be hard to see in my picture, hopefully it's a little bit clearer on your handout. That longer axis is your major axis. So if your major axis is horizontal, we call that a horizontal ellipse. If your major axis is vertical, we call that a vertical ellipse. And I'll show you a little bit as we go how you tell the differences between those. So here is an ellipse. The standard form of the equation of an ellipse is this. It's very straightforward. It's x squared over a squared plus y squared over b squared is equal to 1. Okay, that is the standard form of the equation of an ellipse. Now, let's go through what all these values are. When you write out your equation, you will have the x squared and the y squared still in your equation, but you will have numerical values in for a squared and b squared. So what is a? A is your distance from the center of your ellipse out to one of the endpoints of your major axis. Okay, so from the center out to there is your distance A. The distance B is from the center to the endpoint of what we call the minor axis. Okay, so that smaller axis is your minor axis, and the distance from the center to the endpoint there is B. When you plug it into the equation, the A and the B get squared. Now, depending on the ellipse is going to depend on what goes where, and that's extremely vague when I say it like that, but let me show you what I mean. And this chart at first might be confusing. I'm going to cross out a couple of things right now because this stuff we're going to talk about on Monday. We will talk about all of this. We'll talk about that form of the equation on Monday. But when your ellipse is centered at the origin, this is your equation. Now, if you look over here at this equation versus this equation over here, there's one difference. You'll notice that with a horizontal ellipse, the a term is under x squared, or the a squared term is under x squared. With a vertical ellipse, the a squared term is under y squared. Okay, a squared is always going to be larger than b squared because a squared comes from your major axis. So that's how you can tell by looking at an equation whether or not the ellipse is a horizontal ellipse or a vertical ellipse. So let me give you a quick example, and you don't have to necessarily write this part down if you don't want to, but if you want to, you can. So if I have x squared over 16 plus y squared over 9 equals 1, I know that that ellipse is horizontal in nature because the larger number is under x squared. However, if I had x squared over 9 plus y squared over 25 was equal to 1, I know that my ellipse is a vertical ellipse because the larger number is under the y squared. Okay, so that's how you would tell the difference. And I'm going to talk more about these equations as we go through this video, but that's just to give you a general understanding of the differences between those. The vertices at the end of the major axis, those are called vertices. The ones at the ends of the minor axis are sometimes called co-vertices. I may or may not use that terminology, but I typically only refer to them as the vertices on the major axis and the vertices on the minor axis. That's usually how I would say it. Foci are located from your center is HK, and then you add or subtract C from it. We will go over that as well. One other really important thing to know is this right here. It kind of looks like the Pythagorean theorem, but it's not the Pythagorean theorem, okay? But that is going to help you to locate your foci simply by using that equation. So we know a squared and b squared, will be able to find c squared. Recognize though that it is a minus in there, it's not a plus, so it's slightly different than Pythagorean theorem. Okay, one other thing I am going to talk about is eccentricity. Eccentricity, I can spell it. Is C over A. That just tells you how squished your ellipse is. So if it's really, really narrow, your eccentricity would be closer to 0. If your ellipse is closer to looking like a circle, your eccentricity would be a value closer to 1. Okay, but we'll get to that as well. So I just wanted to get that terminology out there for you. So let's look at an example. How do we go about graphing an ellipse and locating the foci? So by looking at this equation, the larger number is under the x squared, so I know that it's going to be a horizontal ellipse. And I know that the general form is x squared over a squared plus y squared over b squared, the standard form, is 1. So I know that a squared is equal to 9, which means a is plus or minus 3. I know that b squared is equal to 4, so then b is at plus or minus 2. Oops, 2. Let me redo that because that's hard to see there. Plus or minus 2. Okay, so I know that my ellipse is at the center, is at the origin. I know that it's horizontal, so my major axis is along the x-axis. And so I know that I have to go out 3 units on either side of my origin along that major axis, along the x-axis. So I'm going out 3 that way and 3 that way. Okay, the b value is along my minor axis, which goes up and down. And so I'm going from my origin, I'm going to go up 2 and down 2. And those are the only points you need to graph your ellipse. I'm sure I'm not going to be as successful at making this look good as I was at making the circle look good, but we'll give it a shot. So here is, oops, okay, totally lopsided. But hopefully you guys get the idea there. That's really a bad looking ellipse, but that's the general idea there of an ellipse. I totally messed that up, but there you go. So that's how you would graph the ellipse. Now it also says to locate the foci. So to do that, we're going to use the equation c squared equals a squared minus b squared. I know what a squared and b squared are, so I'm just going to plug those values in. So a squared is 9, b squared is 4. So c squared comes out to be 5, which means that c is at plus or minus root 5. So my foci then, because my center is at 0, 0, when it says to locate the foci, you have to actually give the coordinates. So that would be at root 5, comma 0, because I'm going out. Remember, the foci are on your major axis. So it would be plus root 5, 0, and minus root 5, 0. And you do need to write them as coordinates. Let's go ahead and try another one. Now this one, the equation looks a little bit different. It's not in that standard form. This is actually in general form. But similar to circles, only in the sense that we have to put it into standard form to understand what our a squared is and what our b squared is. And so what we need to do is we need this other side of the equation to equal 1. So I'm going to divide everything by 400. Okay, I'm going to divide everything by 400. And now I'll be able to write the equation in that standard form. So if I simplify this, I end up with x squared over 16 plus y squared over 25 is equal to 1. So now I have this in that form that I needed. Now I can go ahead and plot this. My center is still at the origin. My major axis this time is along the y-axis. It goes up and down because my larger number is under y. So my a squared now is 25, which means that a is plus or minus 5. And my b squared is 16, which means that my b is plus or minus 4. So up here I'm going to go up to 5 and down to -5, out to 4 and out to -4. And here's my really bad drawing of my ellipse. Actually, this may have turned out maybe marginally better. I think it looks like a giant egg, but you get the idea. So there is the ellipse with a vertical axis that is the major axis. Let's go ahead and find the foci. C squared is equal to a squared minus b squared. So c squared is going to be 25 minus 16. So c squared is 9. So c is going to be at plus or minus 3. Remember for the foci, and I'm sorry I'm talking really fast, I'm just trying to get this all in one video for you. The foci, again, we have to put coordinates for. Now these are along the y-axis, so our first coordinate is 0, and then we have 3 and 0, -3. Our eccentricity, like I said before, was c over a, and that's just a straight ratio. It would just be 3 over 5, and that's a little bit closer to 1, so you see it's getting close to looking like a circle, and that's all that is. Okay, the last thing on here says find the standard form of the equation of an ellipse with foci at -1, 0, 1, 0. So I know that these are my foci right here and here, which means I know my horizontal axis is my major axis, and my vertices are here and here. So I know c squared is equal to a squared minus b squared. I already know that a is 2. That's this distance here. So a squared is going to be 4. Okay, I know that c squared is going to be 1 because that distance from the center is 1. So I have 1 is equal to 2 squared, which is 4, minus b squared. So I have -3 is equal to -b squared. So b squared is equal to 3. Now, I don't actually have to solve for b because they're just asking me to write the equation. So my equation is x squared over 4 plus y squared over 3 is equal to 1. They didn't actually ask me to graph it. I just put that graph here as kind of a visual aid. They just asked me to find the standard form. I had c squared because I knew what c was. I had a squared because I knew what a was because I had the vertice there. I know I went through that kind of fast, guys, but I just want to make sure I fit it all in. Try the homework. I'll review these major properties on class on Monday before we talk about the new stuff. Have a great weekend. Thanks, everybody. Bye-bye.